Hello, and welcome to my solution on question 2b from the final exam practice problem set. Question is, find the volume of the solid obtained by rotating the region bounded by the following curves. We're going to sketch the region, the solid, and the atypical disk or washer. It's from section 5.2. Two graphs are y equals x squared and x equals y squared. I'm going to pull out a graph, and I'm going to go ahead and graph y equals x squared first. And then in order to graph x equals y squared, I am going to rewrite this as y equals plus or minus root x. Now in this case, I'm only going to have to use the positive root x. I'm going to put that in there now. The axis of revolution is y equals 1, and we're going to rotate around that, so I'm just going to draw it here. And I'm going to do a reflection over the axis of revolution, and that would be my solid. This is the area that I'm rotating. A typical washer will look like this. So this is the outside of the washer, and then the inside of the washer. I have to identify the radii. We'll do the smaller radius first. So that black line right there is the small radius. Now the distance from the axis of revolution to the x-axis is 1, but I don't want the full 1. I want to subtract off this part, which actually is just root x. So the little radius is going to be 1 minus root x. For the large radius, I'm going to draw that in a kind of a brighter color. Be right there. And again, it's going to be 1, but then I have to subtract off this space right there, and that's going to be x squared. So the big radius is going to be 1 minus x squared. Now I need bounds. My left bound is 0, and my right bound, which is b, is going to be 1. Now the formula for the volume is the integral from a to b of pi, and big radius squared, minus pi times little radius squared. Again, that's going to be the integral. Now my bounds, 0 to 1, pi. My big radius is 1 minus x squared, minus little radius 1 minus root x squared dx. Integral from 0 to 1 pi. Now what I'm going to do is FOIL that out, so 1 minus 2x squared plus x to the 4th minus, and then FOIL this, 1 minus 2 root x plus x, and integral 0 to 1, and then I'm going to combine like terms. There's actually none, so I'm just going to reorder everything from in decreasing order. Now, I forgot the pi out here. Sorry about that. So equals pi. I factored the pi out. Now it's going to equal pi times, and then the antiderivative is 1/5 x to the 5th minus 2/3 x cubed plus 1/2 x squared plus 4/3 x to the 3/2. And evaluate from 0 to 1. Okay, it's going to equal pi, and then I'm going to evaluate the antiderivative at 1. Then evaluate the antiderivative at 0, which is a whole bunch of zeros. That all adds up to 11 pi over 30. And that would be our final answer.